For as long as humanity has looked to the heavens, we have been at the mercy of the elements. We have watched our fields parch under a relentless sun. We have seen our homes battered by the fury of hurricanes. We have witnessed the destructive power of lightning. We have witnessed the quiet devastation of a creeping flood. These forces of nature have shaped our civilizations. They have guided our migrations. They have inspired our greatest myths and legends. They are a constant, powerful reminder of a world that operates on a scale far beyond our individual lives. For millennia, our only response was to endure. But what if we could do more than just endure? What if we could command the clouds to release their rain? What if we could steer a storm away from our shores? This question represents one of humanity's oldest and most audacious ambitions. It is a dream born from desperation and driven by scientific curiosity. The desire to control the weather is not merely about convenience. One of the oldest and most widespread forms of weather modification is cloud seeding. The intent is simple: to encourage clouds to produce more rain or snow than they would naturally. This technique is often used in arid regions facing water shortages. For rain to fall, tiny water droplets in a cloud must first grow large and heavy. They must overcome air currents and descend to the ground. They release tiny particles from their wings, often silver iodide. Proving this scientifically is incredibly difficult. Weather is inherently variable, making attribution hard. Hurricanes are among the most powerful and destructive forces on Earth. The most famous of these efforts was Project Storm Fury, a large-scale experiment run by the United States government from 1962 to 1983. The hypothesis was that by strategically seeding the hurricane's eye wall, naval aircraft would fly directly into the furious winds of a hurricane to reach the eye wall. There, they would release large quantities of silver iodide. As this new eye wall developed, it would disrupt the original, more compact eye wall. On several occasions after seeding, storms did appear to weaken, with wind speeds dropping by as much as 30%. The observed weakening might have had nothing to do with the seeding at all. Ultimately, Project Storm Fury was discontinued. Lightning is a raw and captivating display of atmospheric power. While beautiful from a distance, igniting wildfires. The scientific intent behind artificial lightning experiments is twofold. First, by triggering lightning in a controlled manner, researchers can study its behavior up close without having to wait for a natural storm. These rockets are not ordinary. They trail a thin, conductive wire, which is connected to the ground. This channel drastically lowers the electrical resistance of the air, creating a man-made, upward-moving bolt of lightning. Research facilities, such as the International Center for Lightning Research and Testing in Florida, can now routinely trigger lightning on demand when thunderstorms are overhead, and the electromagnetic fields it generates. Despite the success in triggering lightning for study, the goal of using this technology for lightning suppression remains a distant and perhaps unattainable dream. For aviation, fog is a persistent and costly enemy. When thick fog blankets an airport, it can reduce visibility on runways to near zero, leading to widespread flight delays and cancellations. The intent of fog dissipation systems is therefore highly practical. To temporarily improve visibility in a localized area, propane fog seeding has proven effective at several cold climate airports. That means using powerful burners or jet engines of stationary aircraft alongside the runway. Results can appear within minutes, consuming vast amounts of fuel. They clear only a small targeted area, and instead rely on advanced instrument landing systems to guide aircraft in low visibility. The ambition to control weather has not always been for peaceful purposes. The most well-documented instance of this was Operation Popeye, a top-secret U.S. program during the Vietnam War, 1967-1972. Its explicit goal was to extend the monsoon over parts of the Ho Chi Minh Trail. The method was large-scale cloud seeding. Military transport aircraft flew hundreds of missions dispersed silver iodide. They hoped to soften road surfaces, cause landslides. Declassified reports called the program a success, but the true effectiveness remains controversial. The revelation in the early 1970s sparked international outcry. That controversy led to the 1977 Environmental Modification Convention, signed by dozens of countries including the U.S. In the mid-20th century, humanity unleashed unprecedented energy into the atmosphere, a way to develop more powerful weapons. Scientists were eager to study the effects of these detonations. They wanted to understand how the immense release of heat radiation would interact with Earth's weather systems. The method was terrifyingly direct. A nuclear device, sometimes hundreds of times more powerful than Hiroshima, was detonated high above the ground. The immediate result was a brilliant flash of light and sent a mushroom cloud of radioactive dust and debris, known as fallout, soaring tens of kilometers into the stratosphere. It was carried by high-altitude winds and distributed globally. Radioactive isotopes like strontium-90. The global public outcry, backed by scientific evidence of the long-term dangers, eventually led to the 1963 Partial Test Ban Treaty. This agreement prohibited all nuclear testing in the atmosphere. Section 2. Manufacturing winter. The science of artificial snow. The primary intent behind artificial snow creation is commercial and recreational. Ski resorts around the world depend on consistent snow cover to operate. High-pressure water is pumped through pipes to specialized machines called snow cannons or snow guns. At the same time, a separate nozzle releases compressed air, a principle known as the Joule-Thomson effect. The outcome is a landscape transformed. Barren, brown slopes can be covered in a thick blanket of white in just a few nights of operation. A single resort can use millions of gallons of water in a season, contributing to the resort's carbon footprint. Section 3. Riding the storm manned aircraft as weather probes. The intent behind flying manned aircraft directly into severe weather systems like hurricanes and thunderstorms is to gather data that cannot be obtained from a safe distance. Satellites' ground-based radar. To truly understand the engine of a hurricane, scientists concluded they needed to be inside it. This daring approach is essential for improving weather forecasting models and providing more accurate warnings to the public. Lockheed, WP-3D, Orion, Hurricane Hunters. These planes are essentially flying laboratories. They fly in repeating patterns through the storm. During these flights, they deploy instruments called dropsondes. The data collected has provided an unprecedented three-dimensional view of a hurricane's structure and dynamics. This information is fed in real time into computer models, extreme turbulence. These missions stand as a testament to human courage and the relentless drive to understand the most powerful forces on our planet, not by trying to control them, but by bravely venturing inside. Section 4. Summoning rain in the desert. For millennia, the dream of making deserts bloom has captivated human imagination. One prominent modern approach in places like the United Arab Emirates builds on cloud seeding with an innovative twist. Some experiments use ground-based ionizers. Large structures emit charged particles into the atmosphere. The theory: ions rise on thermal currents, releasing videos of heavy downpours in normally bone-dry areas. But the broader scientific community remains skeptical. The core problem is the lack of atmospheric moisture. For now, the dream of summoning rain on command in the driest corners of the globe remains largely a mirage. Tornadoes are one of nature's most violent and unpredictable phenomena that can destroy entire towns in a matter of minutes. The intent behind creating artificial tornadoes is not to unleash them on the world, but to study their formation and behavior in a safe, controlled laboratory setting. A common design involves a large cylindrical chamber with fans to create a rotating updraft of air. They use smoke to make the vortex visible and employ advanced laser-based imaging techniques to map the wind speeds. These laboratory experiments have yielded invaluable insights. By manipulating variables, they have confirmed the critical role of rotating updrafts within a supercell thunderstorm in spawning tornadoes. The energy concentrated in a genuine tornado is astoundingly vast, far beyond anything we can currently influence. The artificial vortex experiments serve as a humbling reminder of the scale difference between our laboratories and the real world. The world's oceans are the great engine of our planet's climate and weather, you know. They absorb vast amounts of solar energy. They drive massive atmospheric currents that shape weather patterns across continents. It is logical, then, that some weather modification efforts have turned their attention to the sea. Some projects aim to harness the immense energy of ocean waves, using advanced buoys and wave energy converters to draw power from waves. More speculative proposals consider covering parts of the ocean with thin reflective films. Those films could increase the ocean's albedo, its reflectivity. In theory, this would cool surface water. Hurricanes thrive on warm ocean temperatures. The sheer scale of the ocean makes such attempts monumental. Covering vast areas with artificial films could be unknown and potentially catastrophic for marine ecosystems. Sea state modeling graphics show how complex and dynamic the ocean surface is. The sea remains too vast and too powerful to be easily tamed by current technologies. Hailstorms are a form of severe weather that can cause billions of dollars in damage. Large hailstones can flatten entire fields of crops, but to change what falls from it, when radar detects a thunderstorm, likely to produce large hail or ground-based rockets are launched. The theory is by introducing a massive number of artificial ice nuclei. This creates intense competition for the available moisture. The effectiveness of hail suppression is one of the most contentious topics in weather modification. Crop damage comparisons between seeded and unseeded areas seem to support these claims. Hailstorms are notoriously erratic. Their intensity and path can change rapidly. Controlled, randomized experiments have yielded ambiguous and often contradictory results. At the same time, we've conducted inadvertent experiments on the atmosphere for over a century through pollution. The particles released from industrial smokestacks and vehicle exhausts, aerosols like sulfates and soot, act as cloud condensation nuclei. Atmospheric pollution experiments, both deliberate and accidental, have shown these particles can alter cloud properties. In some cases, a high concentration of pollutants can lead to clouds with more numerous but smaller droplets. This can suppress rainfall in some regions while potentially intensifying it elsewhere. This unintentional modification highlights the sensitive and often unpredictable response of our atmosphere to the particles we put into it. As concerns about global climate change grow, some scientists have begun to consider a final, deeply controversial category of weather control: geoengineering. The intent here is monumental, not just to alter local weather, but to deliberately intervene in the Earth's climate system on a global scale to counteract the effects of warming. Carbon dioxide removal, solar radiation management, SRM's leading proposal, injecting tiny reflective particles. They would mimic the cooling effect of a large volcanic eruption, but these are still theories. No large-scale geoengineering experiments have been performed. Altered global rainfall patterns, potentially causing severe droughts. Perhaps most troubling is the termination shock, causing catastrophic climate whiplash. Who gets to decide if we deploy such a technology? Whose hand is on the global thermostat? What happens if one country's actions cause a drought or famine in another? Geoengineering remains a technology of immense power and immense peril. Our journey through 15 daring attempts to control the weather reveals a clear and consistent pattern. Our efforts have proven to be small and our control illusory. The atmosphere is not a simple machine to be fine-tuned. It is interconnected. Pushing on it in one place can lead to unpredictable and often undesirable consequences in another. This does not mean the quest should be abandoned. On the contrary, the need for cautious model future climate scenarios. The future lies not in heavy-handed control, but in a deeper, more respectful understanding. Ultimately, the sky does not belong to any one nation or any single generation. It is a shared inheritance and a collective responsibility. The power of nature commands respect, but knowledge. Our path forward is to continue learning and to forever appreciate the awesome beauty and untamable power of the natural world. A world we are a part of, not apart from.